Okay team, here we're going to apply some of these theorems that we've learned over the past couple of lessons. These are AP questions. This particular question is the hardest one on here, so this is why I'm giving you a video of the solution to this one to give you a little bit of feedback. Okay. The other ones are easier, and you're going to use each of the theorems we've used or we've learned exactly once. Okay. So you can take a second to read this one. Please do that if you haven't already. We have two functions here. We have s prime of t, and that's kind of hard to see in this particular formulation here, but there's a prime next to s. And then we have m of t. Okay? And then make sure you zero in on the question here. Apply the intermediate value theorem to the function d to justify that there exists a time t at which the heights of the water in the two cans are changing at the same rate. Okay? So the hardest thing here, we have this function, d of t equals m prime of t minus s prime of t. So at the same rate means m prime equals s prime at a certain t, right? Well, if I subtract s prime on both sides here, I get m prime of t minus s prime of t equals 0, right? So what we want is for this function to be equal to 0 if they're changing at the same rate. Okay, so like the next move is to figure out what this function is, and you already know how to do that. So what we have here is we have m. So we're going to take the derivative of m to get m prime. And I'm just going to leave that 1 over 400 in front. And then 3t to the third becomes 9t squared. So I'm just doing power rule, 60t plus 330. Okay, so that is m prime. And maybe I can make that a little bit more clear. And then s prime is already given to us as 2 sine 0.03 t plus 1.5. Okay, here's where intermediate value theorem is useful to us. Okay, so what we can't do is solve this equation easily, right? Because it's got this polynomial part and then this trig part, the sine part. So figuring out what t would be for this equation is hard, but proving that there is a t is easy. Okay, and the way we would do that, remember what intermediate value theorem says here, right? It says that if the graph crosses 0, then it must be equal to 0 at least one point, assuming the function is continuous. And what we can do is we can just say that the function is continuous because m prime and s prime are both continuous. We'd say, and this is how you can say in the AP exam too, dt is continuous. So the intermediate value theorem applies. So this would be like 1 point on your FRQ, just saying that the intermediate value theorem applies. And then here's how we justify our result. So what we want to do is we want to find d of 60 and d of 0, because those are our two intervals, 0, or the two bounds of our intervals, 0 to 60. And we can just do that on a calculator. So I type this function into my calculator exactly as I see it. I would use the graphing window and then just do calc and value is probably the easiest way to do it. And then type in 60, type in 0. What you get here is 69.377 for d of 60, and you get negative 0.675 for d of 0. So notice this is bigger than 0, and this is smaller than 0. So our conclusion is going to be that d of t equals 0 at least 1t between 0 and 60 by the intermediate value theorem, because d of 60 is bigger than 0 and d of 0 is smaller than 0. Okay. So this is where the heights of the cans or whatever we're talking about are changing at the same rate. Right? So you get 1 point for just saying this. So 1 point for just saying that the function is continuous, so intermediate value theorem applies. And like, even if you can't figure out how to prove it's continuous, you can often just get that point by saying like, just that you showing that you know that the function needs to be continuous. And then you get 1 point for essentially this. D of 60 is bigger than 0 and D of 0 is smaller than 0. Okay? Because that's your justification for the particular conclusion. So I would argue that this problem is easier than it looks, right? So we have this big ugly function, but all we need to do is plug in 2 points to it. You guys have been doing that since 10th grade probably. So as you work through the next couple of problems, look for ways to justify that the theorem you're using applies, and look for the kind of simple math that you need to do to prove your conclusion, because it often is simpler than you expect it to be.